it off to Randy, who actually has a question for all of you about what talk you want to hear.
Yeah.
So, here we go.
Thanks. Yeah, so this is, so when Shauna invited me, thank you, Shauna, you rock.
I was going to say, it's the...
I can fill the room, but...
right there. Try that again.
Oh, okay. Wow.
There we go.
All right, yeah. Okay. Let's see if we can not blow your ears off. Wow. Yeah, so I'm Randy Shoup, and yeah, so when Shauna offered that I should come up and give a talk, I gave her a couple of different options of talks that were sort of all ready to go. She said, I think everybody's going to choose, talk A, and then later is my recollection is like they choose talk B, and then I was going through the emails and the Slack, and I got confused. So I'm going to give you a choice of talk A and B, and by show of hands, which one you want to hear. Does that make sense? And either is fine with me. It's super up to you guys. So talk A is the one that was advertised. So if violation of as we just discussed, literally, if violation of things that were promised is a problem, definitely, say that. But talk A is I titled Pragmatic Microservices, and it's basically about how to make the decision between I have a monolith and should I move to microservices, and when I have made that choice, how to migrate and how to incrementally go from a monolith to microservice. Okay, does that make sense as a conceptual idea? Okay, cool. That is talk A. Talk B is we've decided to do microservices, and here's how you do complicated things around managing data, how do you do the equivalent of joins, how do you do the equivalent of shared data, how do you do the equivalent of sort of transactions, and what are the sort of more architectural, technical techniques to do that stuff. So that is talk B. So, all right, I guess by show of hands, would you like to hear talk A about pragmatic microservices? Here is when and why I would convert from a monolith to microservices. Gosh, I'm going to need some help. Oh, goodness. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20-ish. Okay, yeah, please only one hand each, I didn't say that. Okay, then talk B is managing data in microservices. So we have decided to do microservices, and here are some architectural and technical techniques. Wow, this is close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh my gosh.
So, I would withdraw my vote.
So now 20 to 19?
Yeah.
Or no, 20 to... Okay. So they are both recorded already. So if you Google my name, they both are available, and to the extent that there are show notes or whatever, I can share the links to the videos and the slides. So if you go to SlideShare with my name, Randy Shoup, all one word, there are already ones for both of them. The Pragmatic Microservices is on YouTube from 2016, and then there are a bunch of instances of the managing data one that I've given. So I don't know, by a small margin, the first one?
I was going to say that it's probably a good idea, because I'm also seeing that the more junior people are for the pragmatic microservices that I saw. So I think it's a better up level for
fantastic. And happy to talk afterward, to the extent I'm still awake, about the other stuff. Okay? All right. Pragmatic microservices it is. Great. So I'm Randy Shoup. I am currently the VP of Engineering at Stitch Fix. Stitch Fix is an awesome place to work. Don't be surprised if I tell you at the end we can hire you. But we combine art and science to revolutionize clothing, and we use a ton of technology and a ton of data science to send people clothes that they love. Before that, I was sort of a roving CTO as a service. As I like to say, for about a year and a half, I spent time doing this with companies, mostly startups in the Silicon Valley, but some larger companies in Europe and Asia, about how to be faster, how to take a monolith and break it up, all those sorts of things. Before, I was Director of Engineering at Google for Google App Engine. So that's Google's platform as a service, like Heroku or Engine Yard or Cloud Foundry. And then for about 6.5 years earlier in my career, I was chief engineer at eBay, and I worked on multiple generations of eBay's search engine. So if you've ever gone to eBay and you've looked for a thing and you found it, my team did an awesome job. If you did not find it, it's totally my fault. That's actually true. Okay, because that's what being a leader means. But a little bit about Stitch Fix, because that motivates, some of our need to go from a monolith to microservices. So Stitch Fix is a clothing retailer. You do not come to our site to shop. Rather, you fill out a really detailed profile about yourself. You answer a ton of questions. It'll probably take you, 15 minutes, 20 minutes to answer, 60 or 70 questions. We ask you lots of stuff about, like, your size, your height, your weight, your age, your occupation, whether you're a parent, your price preferences, do you like to flaunt your arms, do you like to hide your hips, like all these kind of like pretty personal questions. And we ask them not to make you uncomfortable, but because if there's somebody in your life, and maybe it's you, that like knows how to choose clothes that are really good for you, like maybe it's you, or maybe it's a spouse, or a sibling, or a friend, what does that person know about you, right? What if they know about you that makes it possible for them to choose, clothes for you? And those are the kinds of things we ask. So then you get 5, hand-picked items, hand-picked for you by an actual human. They show up on your doorstep. You try them on at home. The ones you like, you keep, and you're going to pay us for those. The ones you don't like, you return for free. So you keep what you want and you return what you want. So that is the experience as a client. There is a bunch of technology that goes behind that, some of which I'll share. So we have a ton of inventory, thousands of different styles that we have, and there's a ton of machine learning that we do. So every day we take every piece of inventory times every client, and we produce a predicted probability of purchase. What is the likelihood that if we send Randy this shirt, because it actually came from Stitch Fix, if we send Randy this shirt, what's his likelihood of keeping it, right? So I'm making this up, like 65% chance for the shirt, and I don't know, 57% chance for the pants, something like that. And like we compute those probabilities and update them every day. So that's this, set of algorithmic recommendations over here. Those algorithmic recommendations are given to a human stylist, like we say stylist. There are 3,500 of them all around the United States. They're all employees and they get benefits, and we can feel good about that. But they essentially curate those recommendations, right? So they're going to be the ones that actually choose the 5 items for you in the box. So they might do the thing, they will do things that machines can't do, like put an outfit together, or know what's on trend, or know what a nerdy software engineer in Silicon Valley might wear, or you have a request like, I have a evening wedding in Manhattan and send me something appropriate. And like the machine can't do anything with that, but the human is like slinky black dress or something like that. So cool. So every aspect of things that we do at Stitch Fix is some combination of machines doing what the machines do best and the humans doing what the humans do best. So we have this, we think is unique in the world. We have a near 1-to-1 ratio between engineering and data science. So it needs to be a little bit updated, but we have now more than 125 engineers at Stitch Fix, software engineers, 3 of whom are in the room, so there are 4 of them. I guess if I'm going to count myself one. And 3 of whom live in Portland that are here, but about 80 data scientists and algorithm developers. So that's a huge investment in data science. And so every team that we have, the team that builds the applications for the buyers, and the team that builds the warehouse applications, and the team that builds the applications for the stylists that help them choose the clothes, all of them have corresponding, we say algorithms teams, like a team of data scientists that help to build the models and so on that predict things. And in fact, in the styling area that I just described, the data science team is actually larger than the engineering team, right? So I have roughly 12 engineers that build various aspects of the styling application that shop on your behalf, but there are 25 algorithm developers that have all sorts of different models that are predicting various aspects of that score. Does this make sense? Yeah. It's pretty unique, which is why I'm talking about it. And so, as I mentioned, like we apply sort of this intelligence to every part of the business. So every part of the supply chain in a clothing company, there's some aspect of data science that we use. So what things should we buy? How should we manage our inventory? Optimization of logistics. So that's like optimizing shipping carriers. How can we get the thing to your doorstep, on the right day at minimal cost? The styling recommendations, as I mentioned, and then more standard things like demand prediction. So we are a physical business. We physically buy, actual goods. We store them in actual physical warehouses around the country, and we ship them physically to you, through the mail. So unlike eBay or Google, where I used to work, like that would be if we had like double the amount of demand for eBay, like that would be a cause for celebration. If we had double the amount of demand at Stitch Fix, like that's a disaster. Right? Because it means half of the people we can't serve. Does it make sense what I'm saying? Yeah. So again, my like mental model of like what's an appropriate thing coming out of like purely virtual businesses like does not apply to the physical world, right? They're actually like not just bits, like we're actually moving atoms, and so we need to do that. Have a demand prediction be reasonably accurate in order so that we can predict things properly. And again, as you can see, like all of these things are sort of humans and machines augmenting each other. Cool. So the genesis of this talk was a bit this. So again, I was in my CTO as a service situation. I actually had been talking about microservices for a while, how to do them, why eBay evolved to microservices, why Google did, why Netflix, Amazon, etc. And so I would get startups saying something like this. Hey Randy, tell us how you did stuff at Google and eBay. And I would say, sure, I'll be happy to tell you, but you have to promise not to do them. Not because Google and eBay did things wrong, but this thing that you would do at a 15,000 person company is super not the thing you should do when you're a 5-person company. Does that make sense? Like, they are solving different problems, and not like your problems suck and their problems are awesome. It's like, they are different problems. They are literally 3 orders of magnitude different from you, and so correctly, the solutions to their types of problems are going to be different. And so this pragmatic approach to microservices is a bit like, let's be real a little bit. Like microservices are cool, but they are not the solution to everything. And like, let's try to figure out a way of having a decision rule. Like, what a great phrase. Have a way of thinking about what's the right way to make that choice. Does that make sense? Cool. Okay. So evolving to microservices, eBay is, fair to say, a microservices architecture now, but it was not in 1995. So eBay famously started as a long weekend, Labor Day project of the founder, Pierre Vidyard, and he was like, wanted to learn about this new thing called the web, which, dude, I remember when it was new. Not everybody here does, but that's cool. Monolithic was a monolithic Perl application. It ran on, I always want to say his laptop, but like it probably was not a laptop. It was probably some Windows Tower 486, so he brought that over a weekend. It was very not scalable, but like he wasn't writing a business. Like he was just playing around with this new technology. The next version of eBay was a monolithic C++ application, which at its worst was 3.4 million lines of code in a single DLL.
Wow.
Yeah, so they, like I left it there. All right. They were hitting compiler limits on the number of methods per class, which is 16K. Yeah, so you think you have a monolith, like, you're nowhere near. Like, that was a really good, that was a pretty terrible monolith. So the next iteration was a rewrite in Java. They had baked off, this was like 2000, so they baked off C# and like the .NET ecosystem versus the Java ecosystem. They chose Java, that's cool. So the V3 was a rewrite in Java. It was not microservices, but like I would sort of call them mini applications, if that makes sense. So like there was a Java application for the selling part of the site, and another one for the buying part, another one for the search part, ... times 220 different applications, some larger, some smaller, but like it was more or less like an application per page or set of pages, if that makes sense. And then now it's fair to characterize eBay as a polyglot set of microservices. Twitter has gone through a similar evolution. So Twitter, very famously, I mean, particularly for this crowd, started as like the world's largest monolithic Rails application, which was called what? The monorail. The next, it's true. The front end, so the next iteration was sort of break out the front end into more JavaScript, the back end into services, mostly written in Scala, because Twitter was a pretty early adopter of Scala, and now it's fair to characterize Twitter as a polyglot set of microservices. Amazon has gone through a similar evolution. It started out as a monolithic Perl and C++ application, which you can still see in a bunch of the URLs of product details pages. So if you ever see Obidos, O-B-I-D-O-S in a URL, that was the original monolithic application at Amazon. The next iteration was basically Amazon going dark for 2000 to 2005, essentially, and rebuilding their entire infrastructure along service-oriented lines. So they were really early to this idea. Big credit to Jeff Bezos, right? Like, Wall Street was, metaphorically banging on his door, when are you going to give me some profits? And he said, leave me alone. I'm having everybody do service-oriented architecture. And like, dude, he did it. And look where Amazon is now. Right? Everybody who does retail has Amazon as a competitor. And so now it's fair to characterize Amazon. I mean, they wouldn't actually say the micro in the microservices, but I would. They're microservices, in the same way as Google or Netflix or whatever. So is there like a pattern here? Does there look like a pattern? Please say there's a pattern, because there's totally a pattern. Awesome. But I think there are two things we can learn. One is, nobody starts with microservices. Yeah, like when Pierre was starting eBay, or they were starting Amazon, they built it as a monolith, and there's no shame in that. But past a certain scale, which, by the way, not everybody's going to reach, right? Like, not everybody is going to be at that scale. But if you are, the vast majority of companies that are successful that I can think of have evolved into something that we now call microservices. Does it make sense? Okay, so this is all of the background, and now we're going to talk about like how the companies have made those choices, and what would you think of if you were in their shoes? Does that make sense? But I can't help also making this statement that I strongly believe that if you don't retrospectively look back and go, wow, that was bad, you over-engineered. Why? Because let's do a thought experiment. Let's imagine that in 1995 there was some eBay competitor, some other auction site that like the first thing they did out of the gate was like, well, someday we're going to be really big, so let's build a big distributed system and coordinate in all these ways and distributed computation, and like there's a reason why we've never heard of that company, right? Because they spent all their time building technology and not solving business problems, right? And again, one could imagine a hypothetical Amazon competitor or Google competitor did the same thing. So yeah, I genuinely believe this, that like you should, as part of your evolution, look back and go, wow, I wish we hadn't done that now. But you made the right choice at the time to do something that was pragmatic. Does it make sense? Yeah, cool. All right, so so what are microservices? The micro in microservice, to me, is not like how many lines of code it is the scope of the interface. Right? Is the microservice like simple with a well-defined interface that does kind of one thing or one set of like closely related things? And the key thing is that it's modular and independent. So like my payment service I can use for paying for lots of different things, for example. And then the other thing, which we'll talk about a little bit, is one thing that we learned now that we did not know, or at least the I part of we did not know in the 1990s, is that if you want to call something a service, it should actually own its data all the way down. And so what did not work, and eBay did this in 2008, was what does not work is like, let's have a bunch of services, but have a whole bunch of like maybe one or several databases that are all like shared underneath, right? Why does that not work? We'll talk about this a little bit later, but the intuition is, if I can backdoor go behind your back and like mess around and like even read your data, but God help you if I can like change it, There is no laughter because you're suffering this, I guarantee you. Why are you laughing? It's the laughter with the tears. There's got to be a German word for that. Yeah, exactly right. Yeah, there's some, yeah. It's not Schadenfreude, but there's some German word for like laughing and tears and yeah. Anyway, please tell me what that is if you know it. Anyway, so yeah.
Being on call.
It's being on call. There you go. Yeah. Cool. Anyway, so yeah. Lost my train of thought. Yeah, so if you have a bunch of shared databases, and as eBay did, and other people can like use them behind your back, there's no way you can guarantee any invariance in your system. Like you can't guarantee that any business logic executes. Does it make sense? Like, so your interface, you just basically, your service has no interface boundary. It's just like, I can like go read and write behind your back. Is that making sense conceptually to people? Yeah. Cool. Okay, so that's why isolated persistence. So when I am a service, that boundary is a hard boundary, and like everything, all the data that I store about whatever. If I'm a payment service, like all the data that I store about the state of the payment, like you don't get to see that behind my back. You have to go directly through the front door as part of my interface. Does that make sense? Cool. Okay. Whoops. Didn't work. So, the rhetorical question, and you know the answer already, are microservices the right solution to every problem? I mean, I think no, right? I mean, past a certain scale, they are a thing that helps you scale teams, have people move independently, which we'll talk about, but it is not the right solution. Like, if I'm 5 people around a conference table, it's probably not the right solution to be spending time on building a distributed system. Probably because A, I don't yet have a business model. If I have a business model, I might not yet have product market fit. If I have product market fit, I might not yet know how to decompose my domain. Let's pause with that, right? Like if I'm just starting out and like I'm the first person to ever build, like I don't know, an auction site or something like that, like I might think I know, but I super don't, how to like how that domain is going to need to be decomposed, a year or 2 years or 3 years, right? So it's less about it's wrong to build things out of services, but it's more about I do not know what services to build. Does that make sense? There are only 2 exceptions that I can think of to this rule. The first is if you are building infrastructure. Like if your company is about building like a platform as a service, like App Engine or something like that, it's gonna have to scale. So you are gonna have to think about making it not a monolith simply because part of your minimal viable product is literally that it's gonna scale. Does it make sense? That is not the norm, but that does sometimes happen. The other example that I can think of, or counterexample that I can think of, is if your domain is already very, very, very well understood. And the example I can think of is there are a bunch of new banking startups. Like there's one I can think of called Nubank in Brazil. There's another couple in London whose names I always forget, but they're run by friends of mine, and like they're already doing microservices from the get-go. Why? Because we, the broader we, have known how to build what components are part of a banking system like for freaking 50 years, right? So it is not some like we're new millennials, like we're gonna reimagine like how no dude, the banking's like it's understood how like what the components are of a banking system. It's just like we're gonna build it in a modern way. Does it make sense what I'm saying? Both of those are very rare, but they do exist. So sometimes I get that like, what if I totally understand it? Like if you totally understand your domain, you can skip to this step. But for the most part, people starting out don't really know their domain. They don't know the axes along which they're going to have to scale, all that kind of stuff. Does that make sense conceptually? Cool. Okay. All right. So here's the sort of outline for the talk. I want to talk about monoliths. I want to talk about microservices. I want to talk about how to decide whether you're going to re-architect, like what are essentially the decision rules, what are the criteria to use, and then lastly some tactics about how we might approach one of those re-architectures. Okay. So monolithic architecture. So we like to think people like, oh, I'm working on a monolith, and that like seems a lot of times people say that in a very like shameful or embarrassed way. But there's a lot of good things about a monolith, particularly when you're small. So it's really simple to get started when there's like one thing, right? So you have latencies between the different components of my system are all in process, so they're super fast, right? There's typically a single code base, there's a single deployment unit. I deploy the application, and that happens. And when you're at small scale, it's pretty resource efficient to like keep everything in one place. And the cons are these cons happen, but they happen at larger scale, right? So the cons of a monolith are like, as my team size grows, there's a lot more coordination and sort of coupling, and people are stepping on each other's toes. A monolith gives us poor enforcement of modularity, so if I want to build it out of individual components, the monolith kind of isn't forcing me to do that. If I do it, it's because of my own discipline, but not because I'm forced to do it. As we get larger, the monolith also often has poor scaling characteristics, because maybe the only way I can go is up, I can't go out, if that makes sense, right? I can only vertically scale instead of horizontally. And then it's typically a single point of failure. Does this make sense to people? Cool. So this is sort of the monolithic application. At Stitch Fix, we never built this, but we did build this. So we built a whole bunch of individual applications, some larger and some smaller, but we did absolutely build the monolithic database. And again, I think for the right reasons at the right time. And we're right now going through a lot of effort to like uncouple that. So again, the monolithic database is very simple up front, like all the tables are all there. Join queries are super easy, right? I just add another table to my from clause and I'm good. Transactions are super easy because again, like begin, insert into A, update B, commit, like super simple. And then it's again at small scale, it's pretty resource efficient. At large scale, though, the database becomes a coupling point where all the different parts of our application or applications are all kind of, stepping on each other's toes, and we sort of have to, coordinate with one another. The database becomes a performance and scalability bottleneck, as it certainly is at our company. This, I think, is less well understood than it should be, but if you're using one database for lots of different kinds of workloads, it's actually really difficult to tune it properly, right? So it's difficult to tune one system to be fast reads and writes of individual records, and also really good at large queries that join together lots, a bunch of different tables, and also be really good at bulk updates or bulk loading. So there's lots of different use cases, that we might have in a database, and it's difficult to tune one database to do all of them. And then the last point is that it is a single point of failure. Does this make sense? All right, cool. So we are not yet at microservices, but if we are in a monolith, what could we do to make our lives a little bit better? The first thing is to exploit what I like to call natural partitions in our problem. So lots of domains that we have like naturally cleanly separate into like 2 things or 3 things or 4 things. So obvious examples would be like you're building eBay, and like there's a lot of stuff that buyers need that sellers don't, and there's a lot of things that sellers need that buyers don't. So there's sort of a natural partitioning of the eBay problem into buyers on the one side and sellers on the other. Does that make conceptual sense? Yeah, and if you're going to build a ride-sharing app like Uber or Lyft or something like that, it naturally also partitions into rider and driver, right? So like there's a rider app, there's a driver app, like they naturally kind of partition. If you're going to build Google, a search engine naturally partitions into the thing that crawls the web, so the crawler, the indexer that builds, the index out of the web pages you crawled, and then the query engine that answers, user queries. So again, like if you were going to build like the next Google competitor, first off, good luck, but second of all, like you could naturally partition, it naturally like divides into those three things. Does that make sense? So like take advantage of that, right? So you don't need to feel like, well, I'm going to put like the rider and the driver app into one thing as I start, because they're going to be separate. But I wouldn't start out like with building 100 microservices like as your first go. Having some discipline around modularity. So you can look at me like I'm old enough to remember when we did not talk about distributed systems because nobody built them, but yet we still built software, and we built software out of individual pieces. How in the world did you do that, Randy? Well, guess what? There are these things like shared libraries, and like every language, framework or every language environment has some concept of this. So Ruby gems are a great example. But every language environment has some idea of here is a piece of code that is larger than a class and smaller than an application. Yeah, and it's an opportunity for sharing, and that could be a place where you build a thing that's modular and reusable, and take advantage of that idea. And then lastly, we'll talk a little bit more about this, but I feel strongly that developing a practice around continuous delivery, the ability to deliver things quickly, is going to help you whether it's a monolith or a microservice, and it's certainly going to help you when you are trying to migrate from one to the other, right? Because you're going to want to make a bunch of incremental steps, and you'd like those incremental steps to be like maybe hours or days apart as opposed to months apart. Does it make sense? Okay, cool. All right, so that was a little bit about monoliths. Let's talk a little bit about microservices. So microservices are not, the answer. They don't solve world hunger. The pros are each individual unit is simple, right? That's the idea of a microservice, that you build a service that itself is pretty isolated and simple. The con is, of course, that there are now many cooperating units, and there's some complexity that comes in between the interactions between the microservices. Microservices can be independently scaled, and you can independently deal with their performance. You can independently test and deploy them. So again, hopefully we've made this very simple interface, and so you can write a bunch of tests that test the behavior of that thing from the outside, right, in a very simple, clean way. And then it's possible in a microservices world often to optimally tune the performance of a particular thing. So it may be that, my user authentication service needs a certain type of backend or a certain type of database, or the database tuned in a certain way, whereas my payment service needs a different thing. Does it make sense what I'm suggesting? You actually, because they're solving different problems, you can, but each of them are isolated from each other, you can actually make, if you want to, different choices about how to back that service. I guess a better example is something like, some things are best backed by a database, other things are best backed maybe by a search engine. Yeah? It's some things are just naturally searching problems, and the database is not the answer, but a search engine is, and vice versa. Cool. And the cons are, like I mentioned, there are many services, so there's the complexity comes in how the units interact with each other. We replace those nice in-process, very fast latencies with network latencies. So when I talk between services, I'm typically talking over a network, so that takes longer, and so we have to be less chatty. We do not have the option to do transactions. If we chose the other talk, I could tell you some techniques, but the quick answer is you don't get easy transactions in a distributed system. It doesn't happen. There are ways to get around it, which I won't keep secret. I'm happy to talk about it if you're interested, but it's not as easy as just begin ... commit. And then it does require some more sophisticated tooling and dependency management, because again, there are a bunch of services that are all dependent on each other. Does this make sense conceptually? Cool. All right. So a couple of things that are about being ready to move to microservices. So the one thing that was a nice to have in the monolithic world, like I just mentioned, continuous delivery is an absolute requirement to really get the benefits out of microservices. Why? Well, part of it is just being able to repeatably deploy things, but and part of it is the automated testing aspect. But the advantage is that, let's say if I don't have continuous delivery, but yet I do microservices, okay, then I'm trying to have lots of teams be independent of each other, but they move slowly independently. Does it make sense? If I'm not able to deliver things quickly, and I commit something and it goes through some continuous integration and it ends up on in production. If I don't have that as part of my toolbox, I'm really not going to be able to take advantage of one of the things I'm trying to get out of microservices, which is lots of individual teams being able to move quickly and independently of each other. And, what's involved in that again is, you have a deployment pipeline that, once I say commit or something or deploy, it goes through a series of, things where it tests automated stuff, because I hope you're writing tests, and then it, integrates that thing all together and then, deploys that deployable unit. The other thing to take advantage of microservices is to make sure that your organization can sort of absorb it or is ready for it. And so, who's heard of this thing called Conways Law? A few people. Cool, I'll tell you what it is. Mel Conway in 1968 observed that in the software groups that he was involved with, the architecture tends to be determined by the organization. In other words, particularly the communication paths within the organization determine the architecture of the thing that is built. The flip thing that I think is credited to Eric Raymond is like, if you have 4 teams building a compiler, you're going to build a 4-pass compiler. But the thing about this law is, Conway meant it as a descriptive thing. He was describing what he saw, but we can actually use this in a sort of normative way. We can use this to our advantage. So if the organization is going to determine the architecture, if we want a modular system, then we better start with a modular organization. Does it make sense? Like, this is a little bit counterintuitive, and maybe it feels a little bit backward. But this has absolutely been my experience, that if you have your organization of, I don't know, hypothetically 125 developers like we do, and you build that organization out of like small 5-ish person teams, you're going to end up with a system that is like more modular. Each of the teams is going to build like a little tiny application or a little tiny service, or maybe several, and you're going to end up with something that's more flexible and composable. Whereas if you have teams that, like, the smallest unit of a team is like 25 people or 50 people or 100 people, you're going to build a monolith. Does it make sense why that's true? Because you have structured the organization in a monolithic way, and just because of the way humans are, like, they're just not going to be able to, it's going to be very difficult to build a modular system out of tiny components if you have like really massive teams. And so, the way I like to think about it is, to get the system that we want to engineer the organization. Does it make sense? And the cool thing is we actually can do this, and it actually works. So Amazon, builds their organizations this way. Google does. Netflix does. All of these companies have gotten big and at the same, but still remain fast, right? Amazon seems to get faster as they get bigger. Google seems to get faster. Netflix seems to get faster. Why? It's not because the 15,000 engineers at Google are managed top-down as one unit. Instead, it essentially behaves as 3,000 5-person startups. Does it make sense? I mean, that's the conceptual idea. And of course, there's, they all ladder up into like the Gmail team is like a bunch of different small teams, but they each have their own individual pieces, and they kind of are all kind of composed, they combine together into products that we all use. Okay. I'm going to form one of these organizations, so I'm going to build them out of these, I call them service teams. So teams, and we do this at Stitch Fix, we have teams that are small, so 2 pizza size, to use the Amazon term, so no larger than can be fed by 2 large pizzas. A team has a clear, well-defined area of responsibility directly aligned with the business. Typically, that team is going to build a single service or application, or maybe a set of related services or applications. The teams are going to be cross-functional, so within the maybe 5 people in the team, they're going to have all the skill sets that they need. So maybe they need some JavaScript skills. Maybe they need some people that know about databases. Hopefully, there are some people that know both of those. But regardless of like how the individual skill sets map to the people within the team, it has all the skill sets that you need to do your job are in there. And that doesn't mean everything in the world. Like, I doubt there's anybody here who like builds JavaScript all the way down to Silicon. Probably not, right? Raise your hand if you also build Silicon. Yeah, probably not. Even Google, which does build Silicon, not in one team, right? So, Google designs Silicon, like that's maybe the lowest level. They'll, do their TPUs, like their various chips that are all fancy and, custom. Then they'll have data centers, and then they'll have cluster management, and it kind of layers up from there. And so that's the that's the like conceptual idea of the 15,000 person organization. It's actually composed out of these small teams, but there's a whole kind of layering, if that makes any sense, right? So like there are kind of lower level services, and the higher level services are built on them, and more built on them, more built on them, and then like 8 levels high is like Gmail that we actually see from the outside, something like that. And the teams own these things end to end, right? So they own the service from the design point all the way through to when the service is retired. And that's unlike when I started in software, when we built shrink wrap stuff. Like I was done when I hit commit, and like when my stuff went into the source code repository, and like somebody else, like it went on a CD, or God help me, it was actually floppy disks at one point. And it got shipped to customers, and they operated it, and I had no idea, how that worked. But now, like with this model of like running actual services, like my team writes the code, but also operates it in production. Does that make sense? Cool. Okay. Now let's decide to re-architect. So why would we re-architect? Well, I've heard 3 reasons, and sometimes it's multiple of them. The first and primary reason I hear is like, we are too slow, right? The monolith is so painful to do stuff in the monolith. People are stepping on each other's toes. It's hard to make new employees productive. It's just slowing us down. The other thing that I hear at first level is like it can't scale, right? So like we need to support more load than we have, more users, and we're just running out of gas on the scaling. And then a third one, which is I've never heard as anybody's primary reason, but it's often people's secondary reason, is that there are different parts of our system that want to evolve like at different life cycles, if that makes sense. Like some things are slow changing, some things are fast changing, and it's best if we can have them be individual services, so the fast things can move fast and the slow things can move slow. Does it make sense? Cool. So this is the why. And I guess I'd like to say, the fact that I don't think of it as we had to re-architect as much as we got to re-architect. And what I mean by that is, the reason why you re-architect is because you are building something that somebody cares about, and you have the resources, time, priority to build it better. Does it make sense? Like that's actually a sign of success rather than failure, right? And could we have done things better in the first place? Like maybe. But is it right to say, like looking back from the 15,000 person company, like, oh, that thing we built when we were 5 people, like we were total idiots. Like, no, we were not. We were 5 people, and we were building what was appropriate and pragmatic at that point, and like it's different when we're 15,000. Or again, as I mentioned, like if you don't regret your early technology decisions, you probably over-engineer. Cool. So the last thing is I'll talk a little bit about the tactics for re-architecture. So here's the thing not to do. Martin Fowler, the refactoring book, like he's super awesome and wonderfully sarcastic. He likes to say the only thing a big bang migration guarantees is a big bang. So don't do it that way. Instead, here's the way I like to do it. I like to, and this is how we did it at eBay actually. So I'm gonna like rebuild my monolith in microservices. So the step 0 is like, let's try it out. So we might believe that microservices are the right thing to do, but we really need to try it out in a way that is meaningful for us and our customers. So let's choose, rather than like choosing something that doesn't matter, let's choose some actual vertical experience that actually matters to customers, and either rewrite an existing thing in a new way or build some new thing in a new way. Why? Because it's an opportunity for us to learn, how to do it in a new way. It allows us within our environment, with our people, to sort of demonstrate that it's feasible and gain some confidence in the new way of doing things. And we're not doing it as a big bang because we actually do want to kind of bound our investment in this thing, right? We're not actually sure if it's going to work, so we want to try it out. But at the end of the day, if it doesn't work, we've at least provided some real value. Does this make sense? It's not how most companies do it, but when you successfully do it, you usually start with this. And then, and this is really the hardest step because you're learning how to do things in a new way, and you actually have to build out a bunch of the basic supporting capabilities for it to happen. But then the steps 1 to n are like incrementally migrating the rest of the system. And the counterintuitive way we did it at eBay, which I think is really good, is this. We actually looked at all the pages on the site, and we sort of reverse sorted them by revenue contribution. So like what are the pages that are sort of most relevant to revenue and all the way down to the least relevant. And we actually started with those first pages that were kind of most relevant to revenue. Why? Because we're prioritizing the business value. We're prioritizing like where's the place that has the biggest like return on investment. If we make this part microservice-y and fast moving, like that's the area that like we can actually make some more revenue on. And it also tends to like focus on areas with the greatest rate of change. What's interesting, and this happened absolutely at eBay, was that residual monolith, like it might even still be there. So when I joined eBay in 2004, I left in 2011. When I left, there were still some pages that were on that like scary V2 with the monster DLL. Why? Because they didn't matter, right? So we started with the things that mattered, and we kept like taking them down and migrating them until like we ran out of patience, and like the rest of the stuff like didn't matter. Does it make sense what I'm saying? It's like, again, it's not how people usually do it. They're like, oh, well, let's do the least risky things first. Okay, they're least risky, but they also super don't matter, right? That step 0 of trying it out in a new way, that's the thing that de-risks it, right? That's the thing you have to do. Try it out in some end-to-end, thing that actually matters for customers. And then once you've developed that confidence, then you can like go full bore and like attack the rest of the system in a prioritized way. Does this make sense? Cool. Well, I want to be respectful of everybody's time, so this is probably a good place for me to stop. If people want to leave and have actual lives, like please do that. I'm open for like whenever we have to leave is fine, but like I'm open if people want to ask some questions. So thanks so far. Yeah, thanks.
Thank you so much for that.
Sure.
Is that okay?
I'm open for questions if people want to ask them, if now or yeah. Sure.
That's all Brent first.
So, question about actually the very last point here, because I was chilling for people to come work on our monolith. So if you get to the point where you run out of patience and you say those things are important, why not just delete them? If they're not important, surely they must be so not important as to be worth deleting. If they are worth maintaining, they must be important in some sense.
Yeah, fair enough. I mean, I was being flip. The particular examples I'm thinking of are like support pages at eBay that got like, I don't know, a couple of thousand views a day, and like they were super simple and they were working, and like there just wasn't an ROI to changing it. Yeah, I mean, not important, but not important enough to like bother migrating them. Yeah.
So you were talking about low risk things, low value things and high value things, and pick the highest value part, switch over. Wouldn't that be the highest risk switch over as well? So I'm wondering why you wouldn't pick something that's kind of, I don't know, maybe the 75th percentile, maybe not your highest value, because that's your highest risk as well.
Yeah, I mean, it doesn't necessarily mean, it often is. The honest answer is often the highest value is the highest risk. It doesn't have to be that way, but often it is, to be honest. But the de-risking is this step 0. Like, don't skip this step. So actually pilot it and build the thing, not a toy thing, but build something that's all the way down, right? So I'm making this up, but like, okay, eBay wants to add some new feature, like they want to add, I don't know, automobile sales or something like that. Like, let's imagine that didn't exist. Like, okay, build that in a new way, but build it end to end. Why do you do that? Because again, you get real customer value out of it, and building a thing that's actually real is a great way of focusing. Like, it's a great way of like figuring out what matters and what doesn't matter. But once you've done this pilot and you've convinced yourself, okay, I see, and I've learned a bunch, like there's a bunch of mistakes that I made along the way, and I've learned from them, and like once you've done that, then you can move to this incremental migration. Like I wouldn't start like, hi, we're going to do microservices. Day 1, like let's take the like most painful page and do that. That's what the pilot part is for. That's for that de-risking process. Does that make sense? Yeah. Thanks for asking that, because I was trying to emphasize that, but clearly I didn't do a good job, so thanks for asking that.
So value is kind of one metric that you might want to tackle, but what about like growth? Like, were there other opportunities where you could say, you know, the home page is clearly very valuable, probably the most valuable, but we have other opportunities for growth that might be more important to the business. So, you know, value, growth, and then any other kind of metrics that could be taken into account?
Yeah, sure. I mean, to be honest, I wasn't trying to be super prescriptive about the values, but like ultimately it should be ROI and like what's the R, right? Like what, you know, what's the R? So it may be that you value value, or yeah, like you say, it may be growth, it may be rapidity of change. Like, oh, there's this area of code that's just changing all the time, and like customer-facing like web stuff tends to be like that more than things that are to the back end. And so like maybe that's a place where there is more ROI to like building it in a componentized way. Does that make sense? Yeah. Yeah.
So we are separating things into service because we want them to be separated and isolated, but they still communicate with each other because they're still working together. So you had one slide where you said isolated persistence was really important.
Yeah.
How much do we care about in those isolated databases, data duplication versus, you know, like more calls back and forth to get the data to work with?
Yeah, sure. I mean, that's real design. You have to think about that, to be honest. You know, and I'm not being flip, but like that's actually a hard problem. Yeah. Well, how do I think about data design or data duplication? That was the other talk. But that's cool. It's on the web. The quick answer is sometimes it is okay to duplicate data. Here's my principle very quickly. In your system, there should be one and only one place that owns the canonical piece of that data. So like there is some place in your system that owns the customer canonically, like that owns it. There are other places, like I'll give this specific example. We ship things to people. So we have a representation of customers, probably includes their address. We also have systems that ship boxes to those addresses. I actually don't know this, but Ben does. Whether one could imagine a system that where that fulfillment service, that shipping service, like caches the customer's address rather than constantly looking it up. And it might well be that the customer has moved, so the current customer address is different from where her address was a year ago. And the shipping service is like, okay, well, we sent this thing to her, in San Francisco, and now she's moved up to beautiful Portland, and that kind of thing. So yeah, so the principle is there is one system of record, one canonical place that owns the data and pretty much the rights, W-R-I-T-E-S, the rights should go there. Other places should be, in an ideal world, a read-only, non-authoritative cache. That's the quick answer to duplication of data. Yeah, there's more subtlety there of that, of course, but that was the other one.
Any other?
Oh,
we'll get to you, Paige. Sorry.
yeah.
Oh, fine.
So I heard tons of talks on microservices, and they almost always focus on the messaging, the data arc layer. And I think we're kind of coming into this era where we're thinking about it for front-end architecture, or especially with all the JavaScript frameworks and libraries and things. Can you point at anyone who you think is doing this well, or patterns, or any references for that?
Yeah, that's a great question. I'll first openly admit, as I told you earlier, I'm not a front-end person. Not that is not a secret way of saying front-end is terrible. I'm just not experienced at it. So I'll just openly say that. We talk about microservices, but there's no reason why you couldn't apply all these same techniques to componentizing front-end work. I guess I know enough to know that there have been lots of attempts to build front-end components. I don't know enough to know why they all seem to have failed, but I genuinely don't know why. Like, if I secretly knew, I would say why, but keep trying, I guess. Like, I mean, like, whatever you want to call it, like widgets, like reusable, like, it's a thing. Like, it should totally be a thing. Why it's not a broader thing, I genuinely don't know. But I will say this, that one of the things, well, you know this, but why would other people not in your team know this? At Stitch Fix, we are trying to do a microservice approach to some front-end applications where we're building like little mini applications, and so we're giving that a try. And I mean, I think all the principles apply just as well to front-end, so I mean, that's a great point. Please.
So we should talk about front end. We've been doing that here for a while, so I can talk about it. But I have a question for you, which is, so when we embarked on our microservices journey, I hate that word. When we started doing that, we put together a team of people who were like, here are best and greatest engineers, like, we've not done this before, please do some services. And they're like, okay, we're gonna need service discovery. So they worked on a service discovery system when we have one service. It was terrible. And we still have it around because legacy software was that way, and everybody hates it. So do you have any advice about like specific tactics as you're starting that conversion? Because there's a whole, you just kind of hand-waved over unique tooling, but I think there's a lot there.
Of course, and there's only so much time and so many slides that fit in just to these, or many beers can be drunk and words can be shared.
We have the beers in the back.
Yeah, and now I can drink them because I have that. What is my advice? I mean, what's the flip thing? Like, only build a thing when you actually need it? I mean, only build a thing when you actually need it. Like, that's a principle that applies to every aspect of software. And then I'm being partly flip, but like, I actually really mean it. You need service discovery when you have several, well, when you don't know how to find the services, and when there are so many services to find. I mean, the implication in your question is you don't agree with that order of things, and like, I'm not sure that I would agree with that order of things that you said.
Yeah, I mean, it was clearly a bad idea when we did it. Yeah, don't repeat our mistakes, please. But having been through it at least once, it sounds like, twice now, I was hoping maybe you had some pearls for the crowd.
Well, specifically on service discovery? I mean, I think you can get along.
Well, are there any?
Can we start by defining service discovery?
Yeah, sorry. All right, I am application or service A. I am calling service B. I need to find an instance of service B to talk to. That is my problem. One could talk about that as I'm discovering a particular instance of the service. So does that conceptually make sense? There are many approaches to that, some that are very dynamic and some that are less so. Everything is a trade-off. What we do and what many companies do is we don't really have something that I would call service discovery, but what we do have is a URL that is backed by a load balancer behind which there are several instances. And so everybody knows that I want to talk to the payment service, and you go to, paymentservice.stitchfix.com or something like that, and go there. There are downsides to that approach, but it is very simple and very straightforward, and yeah. So I don't say that's the best way to do it in all cases, but it's a simple way to do it, and it doesn't involve building a framework or a system. Yeah.
Anyone else? Any questions? Going once, twice. All right, you're free to go.
Thank you.
And thank you both to Dana Scheider and